Hi, welcome to the session on Coulombs Law of Electrostatics and electric field intensity. We know that the source of electric field is electric charge. How do we know that there is an electric field at some point in space? How can we quantify the electric field? Coulombs law is the right starting point to find the answers to these questions. Consider 2 point charges in close vicinity of each other. Both the charges produce their own electric field around them. Each charge is affected by the electric field of the other charge. That is, charge 1 experiences a force due to the electric field of charge 2. Similarly, charge 2 experiences a force due to the electric field of charge 1. There is a mutual force between the charges. The Coulombs law quantitatively describes the electrostatic force 2 point charges experience. According to Coulombs law, the force between two electric charges are proportional to the product of the charges and inversely proportional to the square of the distance between them. Force is a vector that acts along the line connecting the charges. The force is repulsive when the charges are alike. The force is attractive when the charges are opposite in polarity. In the diagram, two charges Q1 and Q2 are placed at points A and B. Charge Q1 experiences a force due to charge Q2 and vice versa. If both the charge Q1 and Q2 are of same polarity, Q1 will experience a force F12 from Q2 such that Q2 pushes Q1 away. Similarly, Q2 will experience a force F21 such that Q1 pushes Q2 away. The force is mutual and both the forces act simultaneously. What if the charges are of opposite polarity? That is, Q1 is positive and Q2 is negative, or the other way around. In such a condition, Q1 will experience a force from Q2 such that Q1 pulls Q2 towards it. Similarly, Q2 will experience a force from Q1 such that Q1 pulls Q2 towards it. Mathematically expressing Coulombs law, F12 is proportional to the product Q1 Q2 divided by the distance r squared times the unit vector A12. The unit vector A12 is in the direction of the force which is from Q2 to Q1 for F12. So, we can introduce a proportionality constant K which is equal to 1 upon 4 pi epsilon 0 for free space, where epsilon 0 is the permittivity of free space. The permittivity is a constant related to the medium. It shows the capacity of the medium to sustain the electric field. It will be different for different medium. For free space, the value is 8.854 times 10 to the power minus 12. Thus, Coulombs law in its final form is F12, the force on charge Q1 due to Q2 is equal to 1 upon 4 pi epsilon 0 times Q1 Q2 upon r square times the unit vector from Q2 to Q1. Similarly, if you see the second equation, F21 force on charge Q2 due to Q1, the magnitude is the same except the vector AR12 is changed to AR21. It is obvious that F12 and F21 are opposite in direction, since vectors AR12 and AR21 are opposite in direction. Another observation that can be made from the expression is, if Q1 and Q2 are opposite in polarity, a negative sign appears in the expression. This will change the direction of the force in 180 degrees. That is, pushing force is changed to a pulling force. Next, electric field intensity. Let us again consider the system of two charges Q1 and Q2 at point A and B respectively. Charge Q2 experiences a force due to charge Q1. Charge Q1 at point A somehow affects charge Q2 at point B from a distance. The effect of Q1 reaches from point A to point B. Now, let us remove charge Q2. There is no charge now at point B to experience the force due to charge Q1. That does not mean that the effect of q1 at point B has just vanished. It means that there is no external charge to sense that effect. Just like if you close your eyes, the visible world does not go out of existence, just you chose not to see it. That effect of charge q1 at B or any other point should be quantified. We use the term electric field intensity for the purpose. Say F is the force on a charge q placed at point B. If we place a charge QQ, the force will be 2F. According to Coulombs law, if we make the charge NQ, the force Q becomes N times F. Thus, the force is proportional to the charge placed at B, but the effect of Q1 at B should be independent of the charge placed at B, since the effect is still there even if there is no charge at B. Thus, we define electric field intensity at a point as the force experienced by a unit charge placed at that point. F upon Q bring the term Q to the LHS, which gives a relation independent of Q. See the equation. F upon Q is proportional to Q1 and inversely proportional to the distance between the charge Q1 and the point under consideration. This is the definition of electric field, the electrostatic force per unit charge. Thus, E is equal to 1 by 4 pi epsilon 0 multiplied by q1 divided by r squared times the unit vector in the direction of that point. Thus, this session sums up basics of electrostatics through the understanding of Coulombs law as well as electric field intensity. Thank you.